All right, we're going to wrap up our work with systems of linear inequalities with a challenge and a real-world connection problem. I encourage you to pause the video and try these guys on your own, and then check back in and see how you did. So our first task on the left side is to graph the following system of inequalities. Y is greater than the absolute value of x minus 2 plus 1, and then y is less than 5. So let's get a graph set up here. Looks like numbers are kind of less than 5, so we can just have a typical scale of going up by ones. So I'll label that scale. And I want you to recall our standard form for inequalities, or for absolute value, excuse me. That gives us the coordinates of the vertex. So let's go ahead and graph that up. And it looks like our vertex here will be 2, 1 for this guy. So over 2 up 1, we have a nice vertex. And then we just want to draw in my v. It doesn't look like we've modified the orientation of the absolute value function, and we haven't stretched it or at all either. So I'm going to just have a nice slope of 1 in both directions. And I'm going to turn this into a dotted line because it's supposed to be dotted, because it's just a greater than symbol. Okay, so that is my first one, and that'll be, let's see, I did that equation in black, so that doesn't show up, so I won't highlight it there, but I'll shade it in black right here because we want it to be greater than. All right, let's do the next one. So that was my black equation. Let's do the next one in a better color. Let's do it in red here. Y is less than 5. And so we have a horizontal line at y is equal to 5. 1, 2, 3, 4, 5. And it will be dashed because it's a strictly less than. And I hope you can see what we're going to get. We have this shaded region here. So what's my final answer to this? What's the overlapping region? It's that triangle that you can see where they overlap. And I'll try to highlight that a little bit darker here. So this is our final answer right in there. That would be that's the overlapping region. That's the solution to this system of linear inequalities. Then for our last problem, the real-world connection problem, I'm figuring out how much time I should run and do chores this weekend. I think I'd rather do more running than chores, but I have 6 hours available between the 2 days. And so let's let x equal hours running, and let's let y equal hours of chores. Okay, so I have 6 hours available between the 2 days, so that's telling me that x plus y has to be less than or equal to 6. Okay, I need to do chores for at least an hour, so y is greater than or equal to 1. And I want to run at least twice as long as I spend doing chores. So my running has to be greater than or equal to 2 times my time doing chores. All right, so I'm going to go ahead and graph that up on, actually let's graph it by hand. I was thinking about graphing it up on Desmos, but we can graph it by hand, and let's see what we get. So let's have x plus y as our first one is less than or equal to 6. 1, 2, 3, 4, 5, 6. So this is a standard form equation. 1, 2, 3, 4, 5, 6. And you'll see equations in this form quite a bit where something plus something is less than or equal to a number, and we can just graph it right there. And let me actually try to color coordinate a little bit better here now that I am thinking about it. So let's have this guy be orange. X plus y is less than or equal to 6. So this what I'm graphing right now is telling us what our limitation is just in terms of total hours available this weekend. Okay. Next one for green, let's have, I had to do at least an hour of chores, so y is greater than or equal to 1. So that's going to be this line right in here, and then we can shade anywhere above it, right? And then x is less than or greater than or equal to 2y. I'm actually going to change that into a standard form. Y is less than or equal to 1/2 x. Okay, so I divided both sides by 2, and then I just flipped the whole equation around. So y is less than or equal to 1/2 x. Let's have that be in blue. Let me get this figured out, sorry. Okay, y is less than or equal to 1/2 x. So that has a intercept of 0 and a slope of 1/2. Okay, and we can draw that line in there. And we want y to be less than or equal to that. So we're going to shade this region down in here. So can you see our region of success, our answer region is going to be, try to do it in black, this zone right in there, that little triangle right in there is where we're allowed to be this weekend in terms of making sure all our requirements around chores and hours and running a workout. We can actually do with this is zoom in and see some specific combinations of times that work. Okay, so for example, this point would work right here. That is 1, 2, 3, 4, comma 1. So that would be 4 hours of, what was x again? 4 hours of running and 1 hour of chores would work. And alternatively, we could do something like this right in there. Actually, let me find a point inside. This point would work as well. And so that point is 3.5 comma 1.5. So 3.5 hours of running and 1.5 hours of chores would also fit all of our requirements. And that's a good place to stop.